Okay, hi everyone, welcome to my first D1 video. Today we'll be looking at Dijkstra's algorithm from the D1 paper. This example was taken from January 2009. I hope you find it helpful. Please excuse me if I mess little bits up or it's a bit of a ropey video. This is the first time I've done it, so we'll try to do the best we can. Okay, so let's have a look at this question. You're given a network and you're asked to use Dijkstra's algorithm to find the shortest route from A, which is here, to H, which is here. Fairly standard kind of a question there. Dijkstra's algorithm is all about finding the shortest path from one place to another on a network, and that's what we've got to be able to do. So let's have a look at the page you'll be given in your answer booklet that you'll be expected to fill out. So I've got one here. I hope you can see that okay. You've got the same network but just with these extra boxes, and these are for you to do your workings in. So let's have a look. What kind of workings do we need to show? Okay, so over here we've got the key. So the first box is your order, then you've got your final value here, and your workings can go down here, working values. Right, let's have a look then. So we start off at A, and what we're supposed to do to begin with, we can label that this is the first box that we've labelled, number 1, and here we've basically got the distance from A, the start, to whatever box we're in. Happens that we're in A, so the distance from A to A is 0. So that's kind of obvious. We don't need to do any workings down here to show that. Okay, that's the first step. Second thing to do, we start from where we are, so we're A, and we look at everywhere we can get to. Okay, we can get to B or to C, we can't get anywhere else. And so we fill in some working values. We say, okay, given that it took 0 to get to A, going along this route it would take us 26 kilometers, I think it was, to get to B. So we fill that in as a working value, and then we do the same thing down here. We say, well, it would take 52 to get to C. And very important to fill in the working values properly and not skip them, because you will be marked for that. Okay, now second thing, we take a look around the whole network. Okay, not just where we can get to from A, but the whole network, and look for the smallest working value. So clearly that's 26. So we finalize this box. We say, okay, this is now the second box that we finalized, and the final value is going to be 26. Okay, and now we're here. We're no longer at A, we're at B, and we repeat the algorithm. So we say, okay, where can we get to from B? Well, we can get up here, we could go to D, and to get to D we have to take 26 kilometers to get to B, so add on that 48. 26 add 48 equals 74. Don't be ashamed to use your calculator in the D1 exam, because you don't want to make any little mistakes unnecessarily. Okay, so we could get to D in 74. Where else could we get? We could get to E. So 26 plus 72, that would take 98 to get to E. Where else could we go? Importantly, we look at what hasn't already been finalized. There's no point changing anything if it's already been finalized. It won't be an improvement, and there won't be any reason to do it. So we could get to C, that's not been finalized yet, and that would take 26 plus 25. Well, that is 51. Is that an improvement on what we already had? Yeah, we had 52. Now we've got 51. That's better, so we can fill that in here. Okay, but we don't finalize it yet because we haven't done the third step. So the next step is to look again across the whole network, okay, and look for the smallest working value. So I can see 74, 98 and 51. It seems to me that 51 is the smallest value, available. This one's been finalized, and so is that, so we don't count those. So we'll go for 51. So 51 goes here, and it is box number 3. Okay, cool. So carry on the process. Starting at C, we say, where can we get to from C? Well, we could go up here, but that's already been finalized, so no point doing that. We could go up to E. Okay, so that would take 51, which is the value at C, plus 38. That's 89. Well, that's smaller than 98, so that's a better working value, so we'll put that in there. Oh, what was it? 89. Okay, there we go. Or we could go to F, so we could get 51 plus 71 is 122. So we could get to F in 122. That's possible. Can we get anywhere else? No, that's it. So we do that second phase again, looking across the whole network. So it alternates between looking from where you are to where you can get to. That's one stage that we've just done. So looking across the whole network, don't forget those two distinct phases. So we look across the whole network, what's the smallest working value we can get? 74, 89, 122. Well, 74 is the smallest, so this one gets finalized. 74 goes in there, and we label this as box number 4. Okay, so far so good. Now we're at D. We stay here. We think, where can we get to? Well, there's no point going back down there because it's already been finalized. So the only place we can really get to is G. Okay, so let's fill in the working value. 74 plus 49 is 123. So that's the only working value we can fill in from where we are. So we go over to the phase 2, which is to scan the whole network and look for the smallest working value that hasn't yet been finalized. So we've got 89, 123 and 122 down here, so let's go with 89. Put that in there and label it number 5. Very important to get all these workings right. And then we just repeat. So we're now at E. Same thing again. Where can we get to? Not here, not here. We can get to G, so that would be 89 plus 24. Well, that is 113. Well, that's better than 123, so we cross that out. 113. Where else can we go? We can go to H. Oh, that's where we want to go. So 89 plus 68. That's 157. Working value there. Okay. Anywhere else? No. So now we scan the whole network again. Don't forget to scan the whole network, not just where you can get to from E, but everything. So the stuff that hasn't been finalized, we've got 122, 113 and 157, so it's got to be 113. So we fill that in. 1, 1, 3, and this is number 6. Okay, cool. So now we're at G. Let's have a look to where we can get to. There's only one place, and that's H. So 113, final value here, plus 43, which is that value, is 156. Oh, that's an improvement. Great. So write that in. Then scan the whole network. Don't forget to scan the whole network. 130. Oh, that's finalized already. The only stuff that's not is 122, 156. So this is the smallest value going. So we'll have to finalize this box. I know it's tempting to go straight to H, but we can't. The algorithm says you have to look across the whole network for the smallest working value. Finalize that. Well, that was supposed to be 122, and this is number 7. Okay. Now, where can we get to from here? Well, only one place left that's not been finalized. That's H. So 122 plus 52, 174. Well, that's not an improvement, so we don't have to bother writing that down. Okay, so we've looked at everywhere we can get to, so scan across the whole network. In fact, there is only one place left, that's 156H. This is the only place that's not been finalized, so we will finalize it. And that is number 8. And we're done. So now we know that the shortest distance from A to H is 156 kilometers because H has been finalized. So that answers the first part of the question. Okay, let's have a look, see how we're getting on. No, wrong thing. Yeah, here we go. Okay, we used Dijkstra's algorithm to find the shortest route from A to H, but we haven't found what that path actually is. We've just found that it can be done in, what did we say, 156 kilometers. Yeah, kilometers. But we haven't found what it is. So, second part of the process is to do this idea of tracking back to find the shortest path. And I know some of you will be very tempted just to kind of do it by intuition, but you mustn't do that. You really have to show the workings. So this is how we do it. We backtrack. We start from the end and we consider these three possibilities, and we ask the question, well, which one of these is on the shortest path? So let's take this one here from H to G and we'll test it. And this is how we do it. We take the final value, 156, subtract 113, and it's 43. Okay, show a bit of working. 156 take away 113 equals 43. Now that is equal to the length of the arc. If that's the case, that shows you this is on the shortest path. So we can confirm that G to H is on the shortest path. So we can list that as part of it, and we can do a little squiggle to show that's part of the shortest path. Okay, let me just illustrate that that wouldn't work if it was not on the shortest path. So 156 minus 89 is not equal to 68, it's equal to 67. So that, if that happens, you know this one is not on the shortest path. But okay, we're at G now, so let's try G to D. Let's see, 113 minus 74. Okay, 113 minus 74, that's equal to 39. So D to G is not on the shortest path because we need it to be equal to 49. Okay, so it's probably going to be this one. Let's try it. 113 minus 89. Well, that is equal to 24, which is the length of the arc. So this is good. That works, and we can say that EG is on the shortest path. Okay, and we can do a squiggly line. Okay, where should we go next? Well, let's try BE. Let's test that out. So 89 minus 26, we're looking for 72. 89 minus 26, that equals 63. Oh, that's not going to work. 63. No, can forget about that. Let's go for this one then. 89 minus 51. That's 38. Okay, that's good. 89 minus 51 equals 38. Well, that is the value of the arc, so that works. So we've got CE on the shortest path. Okay, we're at C now, that's good. Well, it's almost certainly going to be... oh, maybe not. Let's find out. 51 minus 0, that's not equal to 52. So this one's not going to work, even though you might expect it to. So that's not what we're looking for, so let's try up here. 51 minus 25, well, that is equal to 26. Running out of space, just keep going here. 51 minus 25 equals 26. That works. So VC, no, sorry. Yeah, this one. That's on the shortest path, VC. So we'll put that in. What did I miss? this one, wasn't it? CE, yeah, CE. So squiggle down there. And finally, surely 26 minus 0 is 26. So that works, that's on the shortest path. But don't forget to show your workings. Some people are very lazy and don't show their workings and then will not get very good marks. So, oh, stop working. Here we go. So there we go. And we can finally list that path. So we get A, B, C, E, G, and H. There is beautiful shortest path there listed out for you. So that will get full marks for all those workings there. Okay, so far so good. Let's have a look at part B of this question. So you've done the hard work, 5 marks in the bag, and then it says there's a fair in village C, so you cannot drive through the village. So we now need to find a new shortest route avoiding C. State this new minimal route, so find the route and its length. Okay, let's go back to our workings. Okay, here we go. So things have changed. So, oh, excuse me one sec. Small brush. Should work. Cool. Okay, things have changed. C is now out of the picture. So that means all the roads going through C we can ignore. So all this stuff we can't use. So forget about that. We need a shortest route that avoids all of that. Okay, so 2 marks for this one, and some of you will find it a bit unsatisfying because we keep telling you not to think in D1, but sometimes they throw in little bits on the end which require you to actually just use a bit of just think it through a bit. So let's have a think. If we can't go to C, from A, clearly there's only one option for our shortest path to H. We've got to go through B. Okay, so once we get to B, we've got 2 options. So it could be that we go up here and down here and then along here, so that's one possibility. Or it could be that we go down here, up here and down here, so that's the second possibility. It could be that we go down to E, straight along to H. So there are 3 possibilities we need to check. Let's just check them. So we got 26 plus 48 plus 49 plus 43. Bit of working. Let's type it in on the calculator, see what it comes to. 26 plus 48 plus 49 plus 43, that's 166. Okay, then we could try 26 plus 72 plus 24 plus 43. 26 plus 72 plus 24 plus 43, that's 165, so an improvement. Plus 72 plus 24 plus 43, that's looking good. Or it could be the third option, going down here and along, in which case we'd do 26 plus 72 plus 68, and that would come to 26 plus 72 plus 68, 166. So it seems to me 165 is the best route, and that was A, B, oh yeah, E, G, H. So there you kind of have to abandon the algorithm a bit and just use a bit of common sense. But if they ask you this kind of thing, it will always be very few possibilities, or there will always be some fairly clear way of doing it. So there we go. That's the Dijkstra's question from 2009 D1 paper. Hope you found it useful.